Hey guys, we're going to go over test number 3. I'm going to go over some of the most missed questions from this test. So the first one that a lot of people got wrong was number 5, and the numbers on your test are probably scrambled. So the first one is this one. What kind of bond would form between ammonium and phosphate? Okay, guys, ammonium is a polyatomic ion. Phosphate is a polyatomic ion. If it ever has a polyatomic ion in it, any type of compound with a polyatomic ion in it is automatically a ionic compound. That's why they're called polyatomic ions, okay, because they form ionic compounds, okay? So that's why that one is that answer. This next question, again, I'm not going to go over every question. I'm just going to go over the most missed ones to keep this video short, okay? And if you have questions about any of the ones I didn't go over, you can send me a chat. Okay, in a bond between oxygen and selenium, which atom would have the partial negative charge? So remember, the one with the partial negative charge is going to be the one with the higher electronegativity. So if we're looking at a periodic table, we have oxygen and selenium. Oxygen has is closer to fluorine, so it's going to have a higher electronegativity, meaning it's going to hog those electrons. So oxygen is going to be the one with the partial negative charge. Okay. This one right here says, which of the following families of elements would have the highest melting points? Okay, this is just directly out of your notes. Word for word, it says that transition metals tend to have high melting points. As you get closer to the middle of the periodic table, melting points tend to get higher. So look at your notes for that one. I believe probably page 10 of your notes is where that's found. Next one I want to go over is down here. I'm going to skip ahead. This one. Which of the following bonds is nonpolar? So guys, if you remember, I told you guys that assume all covalent bonds are polar. All of these are covalent bonds. So I said assume all covalent bonds are polar unless it is something bonded to itself. So like if this was a carbon and a carbon, or a fluorine and a fluorine. Or the only other situation is if you have a carbon bonded to a hydrogen. Carbon and hydrogen have similar electronegativities. And the only way you know that is just because I told you that, and it's in your notes. If you look in your notes under where it's, again, I want to say page 10, where it says, it talks about covalent bonding, and then it talks about polar versus nonpolar covalent bonding. It says nonpolar covalent bonds. Assume that carbon bonded to hydrogen is nonpolar. Anything bonded to itself is nonpolar. Everything else assume is polar, okay? Okay. This one right here, it says, which of the following lists the substances in order of increasing boiling point? So increasing boiling point, that means lowest boiling point to highest boiling point. So the one with the lowest boiling point is going to be the one with the weakest intermolecular forces, and the one with the highest boiling point is going to have the strongest intermolecular forces. So if we're looking at these, the strongest intermolecular forces are, if anything, it does hydrogen bonding. Well, this one here does hydrogen bonding, HF. HF does hydrogen bonding, so that's going to be the strongest. So that's the one that's going to be over here. Okay, then you have to compare fluorine and chlorine and figure out which of these two is going to have stronger intermolecular forces. Neither of them can do hydrogen bonding because they don't contain hydrogen. Neither of them can do dipole-dipole because they're both nonpolar diatomic elements, right? So that means that the only thing that they can do is London dispersion forces. And between the two, if you're comparing London dispersion forces, you go by whichever one is larger. So chlorine is larger than fluorine. It has more electrons, so it's going to have stronger London dispersion forces. So that's why chlorine is the next strongest, and then fluorine is the weakest. And you had to go from increasing, meaning weakest, to strongest, okay? The next one here says, which of the following pictures correctly illustrates the hydrogen bonding in methanol? Hydrogen bonds are illustrated using dashed lines. Okay, so the thing about this one, C, is that the hydrogen, you have to recognize that the partial negative charge is going to be where the lone pairs are. Okay, so and that's where your partial negative portion of the molecule is going to be. The partial positive portion is going to be the hydrogen that's attached to that oxygen. Okay, because remember, hydrogen bonding can only happen when you have hydrogen bonded to oxygen, fluorine, and nitrogen, and that's because oxygen, fluorine, and nitrogen are very electronegative, stealing the electrons away from hydrogen. So that's why C is the answer. It is the only one where it has the oxygen portion kind of hydrogen bonded. Remember, it's not actually a bonded to strong intermolecular force. Hydrogen bonded to the hydrogen that's attached to the other oxygen. Some people put this one, D, but these hydrogens are not getting their electrons sucked away by an oxygen because they have carbon here, whereas this hydrogen is going to be a partial negative area because its hydrogens are getting sucked away by this oxygen here. Okay, so that's why C is the correct answer here. Okay, it's where the partial negatives and the partial positives are attracted to each other. Okay, that one was a tricky one. Number 30. Which of the following compounds would not conduct electricity when dissolved in water? Guys, this question is very similar to one that I saw on a pre-comp a couple years ago. Okay, so what conducts electricity when dissolved in water? Ionic compounds conduct electricity. So it's basically wondering which of these is not an ionic compound. Okay, well, sodium chloride, that's an ionic compound because it's a metal and a nonmetal. Copper iodide, that's also an ionic compound because it's a metal and a nonmetal. This is where a lot of people get tripped up. This one, it does not have a metal and a nonmetal. All of these are nonmetals. However, you have to recognize that NH4 is ammonium, which is a polyatomic ion. And remember, we said up above, if it's a polyatomic ion, it is ionic. Okay, I put this in your notes. I also put it in your study guide. Okay, in the video I made going over the study guide, I said, if it has a polyatomic ion in it, it's ionic. This has ammonium in it. That's a polyatomic ion. So this is an ionic compound as well. This is the only one that's not an ionic compound. This is just a covalent compound. It doesn't have any metals in it. It's not on our list of, none of these things are in our list of polyatomic ions. Okay, so this would be our only covalent one, so that'd be the only one that does not conduct electricity when dissolved in water. Okay, this one says, which of the following best explains why metallic substances can conduct electricity? Okay, guys, metals conduct electricity because their electrons are delocalized. Do you remember that word, delocalized? That means that their electrons are free-flowing. It means that their electrons are not stuck to one nucleus. They move very freely along the surface of the metal, and that's how they conduct electricity. So valence electrons are mobile. Okay. Okay. Number 35. If a substance cannot conduct electricity as a solid, but it can conduct electricity when it is dissolved in water, what kind of bond is it? Ionic. That's just directly out of your notes. Ionic compounds can conduct electricity when they're liquid or aqueous, whereas covalent compounds do not conduct electricity, and metals can conduct electricity as a solid. So ionic bonding is the only one that applies. Okay, number 40 here. In the compound lead sulfate, what's the charge on the lead? This one was tricky. So a lot of you guys put +2. Because you just saw 2 here. And you're like, +2, easy peasy. Nope, guys, I told you, look at the sulfur. What's the charge on sulfur? Sulfur has a -2 charge. Because sulfur has a -2, and there's 2 of them, that's going to be a total of -4 coming from the sulfur. So lead has to be a +4. Okay? So you can't automatically just look at what's over here. You have to think, okay, sulfur might not be a -1. It's not, it's a -2. Okay? So obviously these subscripts were reduced at one point. Also, you know that the lead, the metal, is always positive. That's how you know it's +4, not a negative. Okay, so you can automatically roll out the -4 and the -2. So be careful with these. Guys, these types always show up on pre-comps every single year. So be prepared. Okay, the last one. Which would have the highest boiling point? Okay, so you want to look and see if any of these have hydrogen bonding, because that's always the strongest intermolecular force, which means it's going to make the highest boiling point. So nitrogen bonded to hydrogen, that is the one with hydrogen bonding, because remember, hydrogen bonding happens when you have a hydrogen bonded to a nitrogen, oxygen, or fluorine. So that's why that one's the strongest. These have hydrogen in them, but they're not bonded to a nitrogen, oxygen, or fluorine, so they can't do hydrogen bonding. Okay, that's why that's the answer there. Okay, the overall average for this test was a 78%. So you can kind of see how you did based on that, 78%. If you want to calculate your percentage, you just take the total that you got divided by 44, and that will tell you, and times 100, and that will tell you what your percent was. Okay, if you have questions beyond the ones I just went over, then send me a chat, come to my student hours, ask me, because we're going to have a remediation quiz on this. I'm going to take questions similar to the ones we just went over. I'm going to tweak them a little bit and put them on the remediation quiz. So this should be an opportunity for you to get an easy A and to learn from your mistakes. So take advantage of it.